it's Chris from learngrasshopper.com. Welcome to this beginner's guide to data trees in Grasshopper. If you are new to Grasshopper, you have maybe encountered the term data trees and felt a bit of overwhelmed. Don't worry, you are not alone. Data trees are one of the most challenging concepts in Grasshopper, but they are also one of the most powerful. In this video, we will start with the basics and explain what data trees are and how they work and why they are important. We'll also go through some exercises to help you practice and get better understanding of how to use data trees in your Grasshopper designs. This lesson is one of the lessons from my comprehensive Grasshopper training, where I am taking a user from zero programming experience and going through step-by-step 13 well-structured modules with more than 300 practical exercises. This training is the first step to becoming an engineer for zero with skills that allow automating of the time-consuming work and taking design to the next level. Advanced users will take a lot from this training as well. On the grasshopperfundamentals.com, you can sign up for the next edition of this online training and reserve your seat. I will let you know when the next edition will start and come up with the best offer. Now, let's go to the lesson. Hello and welcome in this lesson called Data Tree Structure. Before we are going to data tree structure, let's make a quick recap about list and data. So first, you've been familiar with a single item. So here we have defined in the panel one value, it's a 1, and when you see on the data, we can use param viewer, and param viewer can give a lot of information, what kind of branches are there and how many elements we can find there. So item is a single branch with single item. If we go to the list, so here we have 9 elements, 9 data in this list, starting from 1 to 9. And if we see with the param viewer, you will see that there's a data with a 1 branch. However, here we have multiple items. So this should be already familiar. You can see already the difference between data, single data with a single line, and you will, when you have a list, we have a double line. So everything should be clear. And now let's go to data tree. So data tree has multiple branches. It means that there are several lists into one list. With the component called param viewer, we can see how many branches are in these data trees and how many elements. So in this case, we have 3 lists in the one data. So here we have one list with elements from 1 until 4. Second, it will be elements from 1 to 7, and another one from 8 to 9. And here with the param viewer, you can see that there is a number of branches. So you can see on the top, on this color, we can see this is a 0 branch. We have branch number 1 and branch number 2, and we have like a correspond item in these branches. So in the first one, 4 items, in the second one, 3 items, and in the 4, 2 items. When you double click on this param viewer, you will see also how the data tree structure looks like. So you will see that there is a green lines that actually corresponds with a data branch. So it's a branch with a small dot at the end with their corresponds with the items in that. So this is actually 3 types of data. There's a single item, list, and data tree. And as you can see right now, then when you have data tree, they have this dashed really thin line that represents that indicates that there's many lists in this data. So let's go closer again with new names about data tree. So first, as I said, this is branches. Every time when you see these curly brackets and some name and some number inside it, so it is indicating that there is a separate branch in the data. Every time when you hover over your data, so you will see, instead of using param viewer, you can also see what kind of data are inside. So this is the branches. The next element is a path. So data still stored in the list. As you can see, there is a same principle, but each list now has a path. And path is the name, always in curly brackets. And there is a number always starting, supposed to start from 0 and go increase values when we go increasing our data tree. So the path are series of indices describing the position of data branch inside the tree. The next one is items. We talked about items, so it's the same as a list because the principles will be the same in data trees as with lists. So inside one list, let's take as a first list with a branch 0. So we can just think about this is just a one separate list. So we have 4 items in that, so we can operate on that list. So this is items, and of course, as it was with the list, there is indices starting always from 0 and going to the number of elements. Another thing that actually you will see that we can extend our complexity of our data tree, and we can give more and more branches. So as our tree is having lots of branches, so here if we have a one branch, so from this branch can be separate lots of another branches. So this is what we can call like a level, like a tree depths. So as I said before, in the curly brackets we have the description of our branch. Here with the semicolon you will see that we can describe how many depths this data tree will has. So first, this is the first level, like the first number before semicolon. It's indicating the first tree level. If we're going to the next one, it will show the second tree level, and the last one, we can say that this is the last tree level. And in this level, the last level always contain items. So there we have some levels, and in the last one, always these items, which you can see right now with the n equal to some number. So you will see items. You cannot find items inside there's another levels. It's always items are on the last level. It's really worth to remember. You can see on the param viewer, you can see that when you zoom, when we zoom to that, you can see that there is a dot that indicates that there is items in that branches. So again, there is like several levels of data tree. You can see right now that first level is like first we divide our data tree into 2 lists, and afterwards this one of the lists, like let's say left one, we divide it into 4, and from that one we have some elements. The same was in the right. So actually this list is growing and giving more levels of data tree. When we see on the data tree, or the order of branches and items is always from left to right. So it's always natural as we create our scripts in Grasshopper from left to right. So order of branches and items are also from this direction. So Grasshopper stores always data in hierarchy with hierarchy. So it's always like some of the levels are deeper, some are not. So just remember that Grasshopper as a principle maintain this hierarchy. Trees grow incrementally and linearly, so there is should not be any gaps between 3 levels, 3 branches. I will show you some bad tree examples. As a principle, it's supposed to be a really linear grow of the tree. And really important to remember that this tree structure can be changed at any time. There is several operations that we can cut some branches, we can add some branches, we can even go further with levels. So remember that this is just a structure, there will be still the same items in that list. However, at any time we can change that structure. So here on the screen right now you can see the bad example of data tree structure when you see with the param viewer. On the left you can see with panel that you have some in the curly brackets some path 0 semicolon 0 semicolon 0, and the next one is 0 semicolon 3 semicolon 0. So you can see that we are missing some data with the 1 and 2. The same, the next one we will going to the 2 semicolon 1 semicolon 0. As you can see on the right in the screen, this is example of this tree. How it looks like, you can see that there is no hierarchy, it's not growing linearly. So this is example of really bad data tree structure, and we always try to avoid this data structure, and as a principle we should not work on the irregular data tree structure because it will be just a problems. It's always wise to create a good data tree structure. So let's create some data tree, and before we go with some examples on the geometry and values, let's stick with the cats and dogs. So we have here two lists. In the first list we have cats, 3 cats, and the second list we have 6 dogs. From the first list, so we can say, like, just to describe this little bit more, so we can say that our list is our home. Let's say that this is a home for these 3 cats. So our list lives in the one house. When we create a data tree structure, so actually we can say that from this house we moved all the cats to the separate houses. So in this case, in our case, we move our cats to the separate lists, and in this way we have created our data tree structure. So in this case, we can say that it will be our city that we can find 3 houses. So again, from the one house, we have created separate 3 houses, separate 3 lists. The same we can do with dogs. So instead of keeping all the dogs in the one house, actually we can separate them into 3 houses. So there is a path, you can see 0, 1, and 2, the same as it was with the cats. So you can see that I created colors that are similar to the same path structure, and we can say that these 3 houses are again a new our city, and we can call it data tree structure. So as you can see, these heart symbols, that this indicates that they are the same as it was with the list. When we operate, for example, make some modification on manipulation, Grasshopper likes to work on the same path structure. So you can see that this first house, like a blue one with the path number 0, will really like to operate with the same path in the another city. So you can see that the same type of the house in the city will operate with the same house of the color and the path in the another city. Of course, we can make some operation on this in this list, so we can switch, so we can move our cats from one house to another. So there is still will be a data tree. However, we can move them reverse, and the same we can also do with our dogs. So if we see it of our city with our 3 houses with dogs, so you can see that there is in one house now lives 2 dogs. Okay, and the second 2 dogs, and the third 2 dogs. So this is how our data tree structure looks like. And as I showed you before, a data tree they has some levels. So for example, in this case, like if we would be more explicit how it looks like in Grasshopper, so it's supposed to be 0 semicolon 0. So we can give the same levels, and Grasshopper will always when we operate on the data tree, we'll always try to find the same path with the same of the one data tree to the path with another data tree. I hope this example with the houses and cities will be simpler to understand. Of course, we are going to go to more advanced stuff, but for now, just remember that Grasshopper would like to operate on the same paths. If we are going to make more operation, so for example, we are moving these two last dogs, I will just repeat this operation. So we have these two dogs that are placed in the one house in the path 2 semicolon 0, and we move it. The first dog will go to the first house, and the second dog will go to the second house. So actually we cut so we call our last data tree structure, our last house, and we move the dogs to the separate houses. We still have a city that contains two houses, and we moved our dogs from the one house to the another. So you will see right now that still we can operate. There is a still heart symbol between first and second house. However, in the third house, there is an arrow in the heart, so it means that there is a cat that cannot collaborate with any of the house from the data tree with dogs. So this is really important, that this is the same example as it was before with lists, that if we have several elements in the one list and several elements in the another one, so Grasshopper really like that in the two lists there are same number of items. The same here will be with the same number of branches and the same paths. If we are going to call the last cat from the data tree structure, you will see that this is a really good match between these data trees, because one city has the same number of houses with the same paths. We can say that number of houses, and the same with the city that are dogs placed. So if we are working with lists, so for example, this is our one house where all dogs are in, and the second list with all cats. So again, the same principle. Grasshopper really like if we will repeat this number of cats. For example, if we make some operation or make the same number. So if we see on these types of interaction, so it's really good that always when we interact with the one data tree to another data tree, so we have this 1 till 1, so we have the same number of houses in the one data tree structure. We can also use one to many. For example, like we have one house in the one city, and we have in the another city we have several houses. So it's also a really good type of interaction. However, we should avoid many to many. So for example, we have two houses in the one and 4 houses in the second one, because it will be hard to understand how Grasshopper works. Let's go to more practical example, and let's say how it looks in Grasshopper. So here we have a list, you can see data tree structure of spheres. On the right side, you can see the data with 4 branches. It means that we have in one data, with these elements, we have 4 lists. Every list, as you can see right now, contains 5 items in every list. So as the graph shows, we have 4 branches with 5 items in every branch. Here it looks like this geometry. I also made in the text on every sphere which branch this item is placed, which branch, the first in the curly brackets, and second in the square brackets, which indices it has. So first of all, let's say I will go to the first example. So let's say that we would like to take this first 5 items. As you can see, there is a 0 in the curly brackets. So we are looking for items which has start with the 0 and curly brackets. As you can see, there is all of those elements are here. So you can see that the indices 0, as here, let me see, I will make the 0 in the curly brackets and 0 indices, so it corresponds with this element. And so on, we go with the curly brackets to 0 in the curly brackets, and the first indices 1, so it's going to this one. So it's going increasingly to the last one. If we go to the next one, so we can say that we can go to the next list, and I will make a quick drawing on that. So this is our second list. In the second list, so we are looking for the branch number 1. So in this case, it will be this branch. So you can see that we have several lists, so the same as the columns placed in every row. So again, if we make some arrows, so let's stay with that we are in the 1, so we are going for the indices number 0 first item, we're going to second one, to the third one, and so on. So this is how this data tree structure is built in the real world example. So this is how we're supposed to think about data trees. It's nothing else than several lists in the one data tree structure. And another example how we can think about data tree structure is that we should supposed to think about that as it is a folder structure. So this is another type of explanation how we can see data tree structure. So let's say that here on the left you can see with the panel there is a data tree structure that contains lots of letters. We start with the first branch, which is 0, semicolon 0, semicolon 0, and it contains 5 items. And we go to the next one, 0, semicolon 1, semicolon 0, which contains 2 elements. So let's present this data in the folder structure. So let's say that we have this data that consists of 33 elements in really lots of different paths. And now we are looking for the first one, which is 0, semicolon 0, semicolon 0, that contains 5 elements. And let's pick just one item from that. So first of all, if we start with the first level, you remember this is the first level. So we have this level which is start with 0, so it's a first folder. And second, so this is we are in the good side. So we are just picking all the first 4 data. So another we see that this data is growing. So the next level is like we have 0, semicolon 0, 0, semicolon 1, 0, semicolon 2, and 0, semicolon 3. So we have these 4. I will just make a rectangle on that. So now we can see that we have these 4 data. However, we are still looking for this particular type, which is 0, semicolon 0, semicolon 0. So again, we need to go to this folder. So let's say that we are going to the next folder. So here we can see that there is our next folder, which is 0, semicolon 0, semicolon 0. This is what we are looking for. And as I remember, I said that always indices are laying in the last data tree path. So here, when we open this folder, 0, semicolon 0, semicolon 0, here we will find 5 elements. This is how it shows in that. If we are looking for a particular element, let's say the first one, so we can see that here, for example, is our first element is a letter A. This is how data tree can be described as well. So let's say, let's find another example. Let's say that we would like to find items that are lying in the path 1, semicolon 2, semicolon 0, and there we have 6 items. So let's find one of these items. So now we are picking the path which starts with 1. This is the first level. The next level, we are picking that elements that are showing just 1 at the beginning. So let's say we now have this 4, 1 semicolon 0, that all starts with 1. So we have a 4. So again, we are going to open this folder. So we are going to open 1 semicolon 2. So this folder we are going to open. And in this open, we can just find one folder again, 1 semicolon 2 semicolon 0. And in this folder contains these 6 items. And let's say that we would like to extract element number 4 with indices number 3. So here we have found element which is letter Q. So remember, this is how our data tree can be considered if you think about that. So here you can extract all the elements that items that link in the last path level. So let's go to this folder and I will show you how it looks like in practice. So when we see on our data tree structure, so we can see like on the folder, so let's open like starts with the 1. With the 1 we are opening the next level, so we can see the level 0, 1, 2, and 3. If we are opening here, so we'll say that we have just one folder, but in this folder you will see that is the last folder, and here we can find just item. So if we click on just item, so here we have, for example, letter D, and another is like a letter R. So you can just open this folder, you can download this below and just play and see how it looks like data tree. If we just come back to our data tree structure, so it's this example, so you can just find the particular types of data in this list, in the items, to understand more data tree. All right, that was a lot of information for the one lesson. I know that this topic is too hard to grasp all the idea of the data tree structure, but the data tree structure is supposed to be complex because they are actually created for managing complex data structure. So step by step, we are going to make some exercises, be familiar with data tree. So for now, you can find the first exercises and just go through it, just solve it. There is about how the data tree is supposed to look like, what is indices, what are the paths, what are the data tree levels. So first exercises is more about write definition and write new names. So good luck and see you in the next lesson. If you like this video and you think it's practical, give it a thumb up. If you know someone who still struggles with Grasshopper data trees, please share it. Maybe this video will change the way of working for someone. Now, I invite you to grasshopperfundamentals.com, where you can register for the next edition and get the best offer from me. See you on the learning platform. Have a good one.